In this lesson, we are going to learn about statistical hypothesis testing in data analytics. For this, we will go back to our Rossmann sales dataset and try out how our promotions impact sales. We are now at our Rossmann sales dataset. Whenever we want to do this kind of analysis, first of all, we need to define our null hypothesis and alternative hypothesis. A null hypothesis means this is the fact which we want to disprove. This is something which is not true at all. So let's say our understanding is that promotions increase sales. So the opposite of this is that promotions have no impact on sales. And this is going to be our null hypothesis. This sounds a bit counterintuitive, but this is how the process goes. You always start with a null hypothesis. A null hypothesis is what you will reject ultimately. And in our case, the fact that promotions do not have any impact on sales is our null hypothesis. So let me create a new sheet and just write this down. Our null hypothesis is that sales for promotion is equal to the sales when no promotion is running. I'll fix my N. Once again, we believe that this is not true. And this is what we are going to disprove. I'll repeat. Our null hypothesis is that sales promotion is equal to sales no promotion, which means that having a promotion or not having a promotion does not make any difference. Of course, our real belief is that it does have an impact. A promotion does have an impact. And what we need to do here statistically is to make sure that we are able to reject our null hypothesis or disprove our null hypothesis. Along with this, we also create what is called as alternative hypothesis. In our scenario, this is equal to that sales or promotion does have an impact on sales, which means that sales with promotion is more than sales with no promotion. This is our alternative hypothesis. This is what we believe to be true, and this is what we want to prove. So long story short, whenever we are given a scenario where we want to see the impact of something on something else, or we create a hypothesis, we always start with creating a null hypothesis. This is what we believe to be not true, and ultimately we want to reject this. And alternative hypothesis, which we believe to be true, and this is what we want to prove. So let's see how do we do this in Excel. If we take one step back, what is it that we are trying to prove or disprove? We are trying to prove or disprove that promotions have an impact on sales or not. So how do we proceed with this? We go to our sales data and extract these two pieces of information. What do we need? We want sales and we want these two entries separately. Sales when the promotion is running, which means promo equals to 1, and sales when promotion is not running, that is promo equals to 0. How we can do this? We can apply filters. So let's start with applying a filter on promo so that we can get all the sales when a promotion is running. So we apply a filter and we take promo when the promo is running. So we uncheck zeros, keep only ones. And here we have all our sales data when promotion is running. We copy this data and paste in a new sheet. Let's say we call this hypothesis testing. and we paste it over here. So now we have our sales data with promotions. Let's rename the heading. And we can count how many data points are there. So we select this and we can see that there are 34,819 data points where promotion was running. In a similar way, we can apply the filter, and this time instead of having ones, we select zeros. Again, copy the sales data and bring into our sheet and paste this over here. Here we rename the heading to sales, no promotion. And if we count how many data points are there, we can see that there are 56,432, which you see in the bar below, that these are the number of data points where no promotion is running. And now our hypothesis is that there is a difference between the sales when promotion is running versus when the promotion is not running. And this is what we want to prove. In Excel, how you can do this? You can use the Excel's data analysis function. Excel has an add-in which you can add to run your hypothesis testing. You can go to Tools and add the Excel add-ins. From here, we can select the Analysis tool pack and click OK. And under the Data tab, you will see that this Data Analysis tab has appeared. So when we click this, we will see some tools. And here we have one of the tools called as t-test, where we are going to do two sample assuming unequal variances. We are going to use t-test because it is one of the most stable testing mechanisms, and it allows us to test two samples. Over here, the two samples are sales with promotion and sales without promotion. And here we are not aware of the variances of these two variables. And since we are not sure, so we can assume unequal variances. This is the most common test which we apply in business scenarios. So we click OK. And here we need to specify our variables. So our first variable is the sales promotion. So we can pick that one as our variable 1 range. So from here till the end, all the 34,819 data points are selected. Hit enter. And in a similar way, we specify the variable 2 range. Again, we go up, select column B till the end, and now it has picked up all the 56,432 data points. So here we have our two variable ranges for sales with promotion and sales without promotion. You need to specify what is the hypothesized mean difference. Since in our null hypothesis, we say that there is no difference between the two ranges, so we specify 0 to be here. Next, you need to specify your alpha. Alpha is the confidence which you want to have in your hypothesis. A 0.05 alpha means the opposite, 95%, which means whenever you will make a claim using this hypothesis, you will be 95% confident that it is correct. So if your conclusion is that promotions do have an impact on sales compared to no promotion, then you are 95% confident that the sales are impacted by promotion. So this is what alpha tells us. 0.05 is 5%, which means 95% confidence. Finally, you need to specify where to store the results. And let's do that we can do that in a new worksheet, or we can just specify where to put it. We can simply put this result in the existing sheet, and here we select output range, and let's say over here in cell E1 we select that, and last but not least we can just put a check mark on labels, because this will then allow us, whatever we are selecting, it will explain and give us a proper label. Let's hit OK, and we get our results over here. Let's see how do we interpret this. So first of all, it is the heading t-test, two sample assuming unequal variances. Here it starts by specifying the mean, and it is specifying the mean and everything for both the variables. When the sales when the promotion is running versus sales when there is no promotion running. We get the mean, which is 7,766, and when no promotion is running, this is 4,176. As you can imagine, already by looking at mean, we can see that when a promotion is running, our sales are higher than when no promotions are running. But we also know that this alone is not enough, because then there is variance as well, there is standard deviation as well. What if mostly the promotions are not having an impact, but only for a few stores there is a huge impact, and that's why the mean is increasing? And if we look at the values for variances, we can see that there are huge numbers. But now let's move a little bit downward. What other pieces of information are here? We have the number of informations. Recall, we just saw this, that the number of entries, the data points for sales with promotion were 34,818, and for sales without promotion were 56,431. And this is a huge sample size. So these are indicating that our data points are huge enough, large in quantity, enough so that we can trust this test. We already specified that our hypothesized mean difference is 0. Our degree of freedom is 76,860, which is again an indication that we have considered sufficient number of data points. This 76,000 is basically a summation of these 2 points. So it means we have considered not just a few 4, 5, 6, 7, 8 entries, rather we have considered over 75,000 data points to make our conclusions. Our t-score, our t-stat is coming out to be 178, and that's a huge number. That's a very large number. Our rejection of null hypothesis and or acceptance of alternative hypothesis depends on how much is the t-stat compared to our alpha versus how much is the p-value versus alpha. The more the t-stat is compared to alpha, it shows that we can for sure say that the hypothesis, which is alternative hypothesis, is correct and the null hypothesis is to be rejected. I repeat, when t-stat or t-score is smaller than alpha, then or closer to alpha, then you can say that your null hypothesis is true. When your t-stat is higher than alpha, then you can say that your null hypothesis is rejected and your alternative hypothesis becomes true. And the more the value of t-stat, the farther away the value of t-stat is from alpha, it means the more confident you are that the null will be rejected and alternative will be selected. Similarly, the values for p-score is the same. It works exactly the same but in opposite direction. If the value of p-score is smaller than alpha, then it means that the alternative is to be selected and null is to be rejected, and vice versa. Here the p-score is so low that Excel has actually truncated it to 0. It has rounded it off to 0, and we can again say that our null hypothesis is to be rejected and our alternative will be accepted. To bring everything together, let's copy our hypothesis over here. So we have our null hypothesis and alternative hypothesis in sheet 1. Let's place this here and read it again. So bringing it all together, our null hypothesis was sales promotion is equal to sales no promotion, which means that promotion have no impact on sales. Our alternative hypothesis is that promotions increase sales compared to when no promotion is running. And our T-stat being very high compared to our alpha is telling us that our alternative hypothesis is true and we can reject our null hypothesis. Similarly, our p-value, which is 0 in both the cases, one-tailed and two-tailed, and we will go through the one-tailed and two-tailed in a minute. In both the cases, it is 0. When it is less than alpha, it again means that the null hypothesis is to be rejected and alternative hypothesis is to be accepted. If we would have selected sales no promotion first and sales promotion as the second variable, we would have gotten a minus sign over here. But signs do not matter in this case. The absolute value of T and P score, they matter. And last but not least, this one tail and two tails, they basically show the directionality. When we say that our null hypothesis is that sales are not impacted by promotions, which means no promotion sales is equal to the promotion sales, and our alternative hypothesis is in one direction. We are talking about increase. We are saying that promotions increase sales compared to when no promotion is running. We are talking about the increase only. We are talking about one direction only, and in this case, we are talking about one tail. When we had to consider both the directions, which means does promotion increase sales or does promotion decreases sales? When we are talking in two dimensions, when we have to consider both the directions, increase and decrease, in that case we consider the two tail. In our scenario, in either of the case, either one tail or two tail, basically the p score is way less than alpha, which again says that the null hypothesis is to be rejected and alternative hypothesis is to be accepted. The values for the T critical one tail and the T critical two tail, this 1.64 and 1.95, they are coming from our statistical background and they depend on the value of alpha. And that's basically it. What we have just done is to use statistical hypothesis testing to prove our hypothesis that whether promotions have an impact on sales or not. And this is how you use statistical information to make business decisions.